All right. So we are going to add to the notes we took over the weekend about the net change. We're going to add one more situation. Today is going to be like a calculator / no calculator day where a lot of these problems you can do by hand. But there's a point where we've done so many of them by hand that we're kind of like killing it dead and we don't really need to do that as much. So there will be a point where we'll kind of transition into like, yes, you're capable of doing it by hand, but we're just going to use a calculator to make it go faster. So for this first problem, we're going to say, and actually we're only going to do one example. It's just going to be asking some slightly different questions from the video over the weekend. So we're going to say a particle's velocity is given by the equation v of t equals t to the third minus 2t squared plus 4, where t is in minutes and v of t is meters per minute, and S of t represents the particle's position. And we're going to answer just a few questions on this that use the idea of net change, and just make sure that when we word things a little differently that we understand how to find the answers, and that we can do it with a calculator and without. So for the first part, we're going to find the net change in the distance over the first 5 minutes. So how do we write that using integrals? So the integral, or the sum, from 0 to 5 of
v of t,
v of t dt. Okay, so that's what we're going to find. When we calculate it like this, are we finding the displacement of the particle or the total distance the particle traveled? Wait, remember what the two things mean. So displacement is like the location that you're at. You could have gone back and forth. Total distance is saying you went forward 5 feet, you went back 2 feet, you went forward 17 feet, you went back 7 feet, and we are just adding up all those little distances together. So which one is this? This one is displacement, okay? So when they're talking about the net change, and it only really matters for problems like this, where it's something where you could have gone forward and backwards. So when they talk about net change in this situation, they're talking about displacement. If they want total distance, they will say total distance.
What does displacement mean again?
Displacement is like when I say I live in Raleigh, so my displacement right now is 20 miles from Raleigh. Total distance is I travel 20 miles to work and 20 miles home every day, so I travel 40 total miles each day. So displacement is how far you are from the starting point. We said that was like end minus beginning. Total distance is adding positive and negative distances together to see what that full amount would be. So the one thing that's going to change, you're going to start to be able to recognize this really easily in these problems, is that when you find total distance, you're going to use an absolute value sign so that you can add up all those distances without any canceling out. Okay, so we're going to go ahead and do this problem by hand, find the net change in the distance over the first 5 minutes. So that means I've got the integral from 0 to 5 of t to the third minus 2t squared plus 4 dt. And how would I do that by hand?
Add 1, divide by that number.
Divide by 4, add 1, divide by 3. What do I do with the 4? Yeah, or a t, right, in this case? Okay. So we have 1/4 t to the fourth minus 2/3 t to the third plus 4t. Do I need to put a plus c?
No.
No, why not?
Because you're not finding. Because it's an closed interval.
Yeah, it's a definite integral. And so I do from 0 to 5. Okay, and then what do I do?
You plug in 0 and 5.
Plug in the 5. Okay, so I've got 1/4 times 5 to the fourth minus 2/3 times 5 to the third plus 4 times 5
Then you minus that.
with the 0 plugged in, right? Yeah, which is 0, thank goodness, because this problem is not looking nice. So that's 0. Okay. So for this first one, we have 1/4. Anyone know their multiples of 5? Or their powers of 5, I guess? 5 squared is 25. 5 to the third is 125. 5 to the fourth is 625. 5 to the third is 125. So we have 625 over 4 minus 250 over 3 plus 20. And this is where I'm going to tap out and grab a calculator. It's not that I couldn't do it, it's that I don't want to. I'm the only person allowed to use that excuse, by the way, not you guys. Okay, 92.917. What are the units on that answer?
It would be meters per meters.
Is it meters per minute or meters?
Because if we divide meters, we're not finding a rate.
Yeah, we're not finding a rate, we're finding a distance. So if we go back up here and we think about our rectangles, the height of our rectangle would have the units meters per minute, right? So V of t is the height of our rectangle, that's meters per minute. dt is the time, right? And that's the width of our rectangle, that's minutes. And minutes cancel and we just get meters. So if you're ever doing an integration problem and you want to double check what your units are, just think of the units of your problem times the units of your time, and that's going to give you the units for your answer. So the units for our answer is just meters. All right. How could we plug that in on our calculator to double check that our answer is right? Math 9. You could do it graphing it, right? We could graph the curve and find it that way. This is going to be a little faster. So from 0 to 5 of, do we plug in this part that we found, or do we plug in the original?
The original.
We plug in the original. Okay, so x to the third minus 2x squared plus 4 dx. Now, I did this in terms of x, but if you're like, Ms. Rice, it's in terms of t. You can actually go back and you can make these all t's. Alpha t, alpha t, alpha t. And your calculator can do that just fine too.
Could we just as easily use x?
Yep.
Instead of, okay.
Yep. So in your calculator, you can use whatever variable you want. Yeah. If you're like, I want to use n every time because my name is Nancy, then that's fine. You know? All right. Let's do the next part. So next we're going to say find the total distance traveled over the first 5 minutes Now, we've done a problem where they told us, where they might say, evaluate this interval from 0, or this integral from 0 to 5. And we said, oh, it was the total distance traveled. But the reason we said that is because the original problem said that the function was only increasing. And if it's only increasing, that means it did not backtrack. Does that make sense? Okay, so it is possible for the original integral to give you a total distance, but it would be wrong to assume that that is the case every single time, unless you already know what that function looks like and you know that function only increases. Okay?
So if we were given like a quadratic for our velocity, we would see that we would know that it goes from increasing to decreasing.
Yeah, so we would know that a function like that would switch directions, and so we wouldn't assume it was a total distance. We would assume that it would be a displacement, versus if our velocity was a linear function and we knew it had a positive slope, then we would say, yeah, that's always increasing. That would be our total distance as well as our displacement at the same time, because we never backtracked. Yeah. Okay, so if we're going to find the total distance, all we have to do is we're going to do the exact same problem, so the integral from 0 to 5, but we're going to take v of t and we're going to put it in an absolute value sign, so that when we find it, it's going to give us the absolute value of the distance, and then whatever left movement, whatever right movement, everything we do will be positive, and we can just add all those movements together. Okay? So what we're going to do is we're just going to plug this in our calculator. So math 9 from 0 to 5, and instead of just typing in the problem like I did last time, I'm going to hit the math button and go over to absolute value, and I'm going to type it in as an absolute value. Does that make sense, the difference between what I did last time and what I'm doing this time? Okay, so that means that instead of having negative distances when I go left and positive distances when I go right, it's going to call all the distances positive. And so my answer is going to be the total amount that I traveled both ways. So if my two answers are the same, what does that mean? Yeah, it didn't switch back and forth. It only went one direction. Okay. All right. So we're going to say this equals 92.917 meters. And I'm going to say, so the particle didn't switch directions. This is one of those kind of subtle things that we have to pay attention to in the FRQ questions that we do, because oftentimes they'll ask us to interpret our answer. And when you interpret your answer, you want to make sure that you know the difference between a displacement and a total distance, because math students typically default to saying something is just a total distance, and they say that every single time, even if that's not always the case. All right. Okay, part C. We're going to say if s of 0 equals 5, then what is s of 3? And we're going to go ahead and solve this 2 different ways so that you guys can see that there's various methods for this. And the first way that we do is going to be kind of like what's in our brains as of what we've learned so far. And the second way we do it is the easier way. Okay, so we're going to learn something new about this today. So the first method would be to take the integral of v of t and figure out what your s of t equation is with the plus c in there, and then plug in the specific value so you can solve for your c so that you know what your s of t equation is. And then you can evaluate your s of t equation. Okay? So we're going to, I was kind of laying out the big picture, and now we're actually going to do it so you can see it. Okay? So we're going to say solve this problem using s of t. This is the first of the 2 methods that we're going to use to do this problem. So the first thing we could do is we could do the indefinite integral of v of t dt, because when we do the indefinite integral, then that's going to give us s of t. Okay? So if I find the antiderivative of the velocity, that gives me the position. Okay. So the antiderivative of t to the third minus 2t squared plus 4 dt, we have already done the work to find that, right? Mm-hmm. So we already know that that's 1/4 t to the fourth minus 2/3 t to the third plus 4t. But this time it's an indefinite integral. So what do we have to do this time? Plus c. And this equals our position equation. So now I can use that piece of information where I know that if I plug in 0 for t, I'm going to get 5 as a result. So I'm going to say f of 0 is 1/4 times 0 to the fourth minus 2/3 times 0 to the third plus 4 times 0 plus c equals 5. So if I plug in 0, I get 5 as a result, and so that tells me that c equals 5. So that means that at this point, I know that my s of t equation, my position equation, must have been 1/4 t to the fourth minus 2/3 t to the third plus 4t plus 5. That was the original equation they used to find the velocity. And now that I know that, what can I do to find s of 3? Plug it in. Okay. So s of 3 is 1/4 times 3 to the fourth minus 2/3 times 3 to the third plus 4 times 3 plus 5. At this point, yes, we can handle that math. It's a little bit overkill to keep doing stuff by hand. So I'm going to say 1/4 times 3 to the fourth minus 2/3 times 3 to the third plus 4 times 3 plus 5. This is 19.25. Okay, so based off the methods that we have learned in class before, that is how we probably would have completed that problem. Okay, that makes sense? All right, now there's another method for doing the exact same problem that is actually easier, where you can use your calculator and not find the position equation at all. You don't even have to find it, you can get the answer without it. So the other way we're going to do this exact same problem is we're going to say to solve using integrals. And we used an integral last time, so this time I'm going to say definite integrals.
Before we use position equation, right? As of using as of.
Mm-hmm. Yep. So before we solved using the position equation, this time we're going to solve using definite integrals. So the method that you use for solving using definite integrals is you say, if the value at 0 is 5, then I'm going to say I will take 5 as my initial value, plus if I want s of 3, then I just need to know what the integral from 0 to 3 is. And doing it this way, I never have to know what the original equation would have been, what the position equation was. So this says 5, that's the initial value, plus 0 to 3, the definite integral from 0 to 3 of v of t dt. And we're going to do this by hand so that you can see exactly what it is. And then after this, when you do it in your assignment today, you can do it in a calculator. Okay? So if we do this problem by hand, then we're going from 0 to 3 of t to the third, what was the problem? Minus 2t squared plus 4 dt.
How did you get the interval 0 to 3?
Because it said s of 3. So my initial value was plug in 0 and I get 5. and then I wanted to find s of 3, and so that means I was using the integral from 0 to 3. Thank you. Okay, so to do this by hand, we would say 5 plus, and we've already found this antiderivative multiple times, so I'm just going to write it down. This is the 1/4 t to the 4th minus 2/3 t to the 3rd plus 4t. If I'm doing a definite integral this time, do I need to have a plus c? No. Okay, so now I say from 3 to 0. Okay. So now I have 5 plus, and then I have to plug in 3 and plug in the 0 and subtract those values, right? So if I plug in 3, I've got 1/4 times 3 to the 4th minus 2/3 times 3 to the 3rd plus 4 times 3. Right? And then I'm subtracting off 1/4 times 0 to the 4th minus 2/3 times 0 to the 3rd plus 4 times 0. And this part right here zeroes out. And if you compare this part right here, it's exactly the same as s of 3. Do you guys see that? Mm-hmm. So the 5 that we had in the front represents our c value. And then the definite integral excludes the c value. So by writing it the way we wrote it, we get the c value in there for our specific problem, plus the extra that we get by doing the from 0 to 3. Does that make sense? Okay. So it's exactly the same problem. You get the exact same answer. It's just 2 different ways of going about it. This one, if you're doing it in a calculator, is definitely less work, because you can literally type in 5 plus from 0 to 3 of that original function, which was x to the 3rd minus 2x squared plus 4 dx, and it will go right to that 19.25 with a lot less work. Does that make sense? Okay. So I want to do another example of just using this method right here, so we can see how quick it is when you do this method from start to finish. Okay? So we're going to say, if I give you the problem that f prime of x is 3x squared minus 8x plus 9, and f of 5 is negative 16, and I want you to find f of 10, then the process we would use for this is we would say negative 16, because that's the value they gave us, plus the integral, and since they said they plugged in 5 to get negative 16, and they want us to plug in 10, then our integral is going to go from 5 to 10. Okay? So it doesn't have to be 0 for this to work. All right? 0 is the easiest way for you guys to see how the problem connects, but it works with all other sorts of numbers too. So f of 5 is negative 16. That's my plus c value. That's what would have helped me get to there. And then I'm saying from 5 to 10 of 3x squared minus 8x plus 9 dx. And I could do all of that by hand, or I could just plug it straight into a calculator and go from there. So 5 to 10 is 604. That's like a 30-second problem now. Okay. Does that make sense? So two different ways of accomplishing the same thing, but using integrals, it's so much easier. Okay? So remember, the reason it works that way is because this is a definite integral, and definite integrals ignore the plus c. And this part right here is taking the plus c into consideration. So this is us getting our plus c, this is us getting the rest of it. So we have the whole thing. Okay? All right, any questions? No? Okay.